Whether you use a dollar bill, a spoon, or a shoe, you know that opening a bottle can sometimes be difficult. With a force gauge, you can even see that it requires about 114 newtons of force. Using a pretty respectable 7-inch bottle opener, it only takes about 16 newtons of force. But as a lazy human myself, I figured why not take this mechanical advantage to the extreme and see if even a banana can open a bottle. The concept of mechanical advantage is rather simple. To generate the required moment with less force, you can push from further away from the fulcrum. Then this moment is translated to the shorter moment arm, meaning the tooth pushes with more force and actually pops it open. Putting numbers to this, you get a required moment of around 104 newton inches. And I know that's an infuriating unit, but it will work just fine. Before we move on, I need to point out that this simple calculation is actually missing something. Although it won't have a huge impact in this case because the angle is small, you need to use the component of the total force acting perpendicular to the moment arm, not the total force. If you don't see why, think of it like this. If I push on the bottle opener like this, I may be exerting force, but it's not contributing to any rotation. I need to only use the force acting this way. To account for this, I can use simple geometry to separate the components of the force into the force acting perpendicular and parallel to the moment arm. And then I'll only use the component acting perpendicular for the calculation. After this adjustment, the required moment to open the bottle is now about 97 newton meters. For the longer 31-inch bottle, if you do the same calculation but this time solve for the force needed to achieve the required moment of 97,